Hey, hello. Right. It's been a long while since I've done one of these. I haven't even adjusted where the camera is. So, apologies for the sort of late notice of this stream at all. I don't suppose most people are up at this time. But I thought I would do a little bit of a catch up on where I am with the path tracer. So, the story so far is that about 3 months ago, when I was on a break between jobs, I came up with an idea for a CppCon presentation on path tracing, which is like my go-to go-to sort of project to learn a new language. So far, when I've learnt Go and Rust, I made a little path tracer in each language, and that kind of taught me a little bit about what that language offers. And it occurred to me that I hadn't done one recently in C++, and C++ has changed a lot. So I thought I had this idea for doing a path tracer 3 different ways, using 3 different styles of C++, and sort of then I could compare and contrast. And a path tracer is a cool thing to write anyway, and ends up with lots of interesting pictures at the end of it. It's very similar to a ray tracer, for those who know what that is. And I'm not going to go into huge detail on what that is now. So 3 months ago, I had this idea, and I started working on like the skeleton of the project, and I live streamed probably the first 5, 6, 7-ish hours of development of the path tracer. And in fact, what I should probably do now, this is all on GitHub. If you go to my GitHub and then search for pt-3-ways, you'll find the code, so you can follow along, and it works. On other machines, I've been running it at work a little bit, and I've been running it on AWS, which you'll hopefully see in a second. And it's a CMake project. Just grab it down, load it up in your favorite IDE, and just CMake, and you're off. So where are we with it? When I finished off doing the 3rd or 4th, I can't remember how many I've done, of these live development podcasts, we were in the situation where I was getting some kind of picture. I think it was just a sphere, like a coloured sphere. And that was great, but not very interesting. And it was only done one way. I was done it the object-oriented way. So the 3 ways that I, at the time, were planning have changed. And now the 3 ways are object-oriented, functional, and data-oriented design. So the first 2 you may well be familiar with, but data-oriented design is more of I perceive it anyway, more of a sort of special case games industry type thing, but it lends itself very well to this kind of problem, I think. So, well, we'll see. I haven't got that far yet. I haven't really done anything explicitly data-oriented design before, although 12 years ago when I used to make video games, it was kind of something we did anyway, I think. We'll see. I've been watching a lot of YouTube videos on what various people think of as data-oriented design, including Mike Acton's CppCon presentation. So, that's where we are with this. Let me load up some code, and meanwhile we'll sort of talk a little bit about the styles, because let me fire up Sea Lion. One of the interesting things is that as I've been writing this, I realized that the first iteration of this, where I wrote the code sort of in my sort of natural style, is kind of a blend of all of the things. So it's worth saying there will be some spoilers for my CppCon talk in this presentation. So if you really want to keep the surprise for next month, then tune out now. The thing that I've found surprising is that what I was thinking of, I think of myself as a very traditional OO kind of person. And now, once I started doing the functional programming version, I realized that some of the things that I do in OO are really FP type things. And as a result of trying to come up with the contrast for the 3 different styles, I'm actually having to undo some of the more, undo some of the more traditionally FPE type things that are totally reasonable to do in an OO context, take them out of the OO version and then put them in the FP version just to show. And obviously, I think it'll be fairly clear that when we get to the end of all of this, the conclusion will be we use C++ for the reason of being allowed to blend between all of these sort of language constructs and take a bit of each. And that's probably the best version. But there you are. I've spoilt the conclusion, but I haven't made that conclusion fully yet. So we'll see when we get there. So yeah, so you find me just starting to spike the sort of data-oriented design version, which is looking very exciting and very promising right now. Just as of a note, when I was running this before, towards the end, I realized when I started doing any kind of rendering and using more than one CPU, that the live stream software would drop out, which is kind of makes sense, really. I mean, at the moment, if I bring up my terminal, wherever that's hiding, and just look at the CPUs I have right now, well, at the moment, X Windows is taking up all of the speed. Oh, cats. Oh, and Spider Oak 1, that's my backup solution. I think I probably need to suspend that for a bit. But yeah, right now we can see that, yes, OBS, which is the streaming thing that I'm using to actually stream this, is taking up some CPU. But there's a lot of things that are fighting for that CPU, and I don't have that many CPUs on my laptop. So what the fine folks at JetBrains have got in their IDE is the ability to add a remote host to both compile and run your code on. So you can see I have debug and release, and then I have debug and release AWS Beast. That is a AWS instance that I've just rented and hopefully set up right. Here it is, hello. And it should have a version of CMake and all the things that I need on it. And effectively that ends up being the place where the code will build and run. So while we're talking, I'm going to just try that now. And what shall I do? Let me do the 16 samples version. So I'm just going to build that and see if this works first of all. So far, so good. Excellent. And now if I run this, it should actually run not here, but somewhere off east of here. Yeah, that way's east. Yeah, you can see like this is not the normal directory on my machine, /tump/ whatever. So that's going a lot faster. And when it's only using 6 CPUs, that's daft. Whoops, let's stop this. And I'm going to say num CPUs 0, which is my special for all of the CPUs. The default is 1, so it doesn't crush your computer. Right, let's run that now. And this will be building just a 16 sample version. So path tracing. Path tracing is, like I alluded to earlier, something very much like ray tracing, where you fire a ray for every pixel in the camera and you find out where it lands, and then from that you determine what color it should be. And to some extent, you know, your traditional games, well, certainly games 10, 15 years ago, that's kind of what they did. They did one single fire out of the camera lens, although they turned it around and said, where does this triangle land on the screen? Somebody has just said Visual Studio Code has something similar to this remote feature. That's cool. I haven't really used it. Okay, the problem we have here is that image is on this computer, which, oh, actually, I didn't think. Let's see, where did it end up? It'll be in this directory. That's unhelpful. So I'm going to go to my local computer and I'm going to SCP that from whatever the heck the IP address is of this machine, which I've already forgotten. Let's just do this. History merge, and I should get the history, and it should be, I think it's 3 something something something. Let's get that. Yeah, there we go. I love fish shell. And this will be called the rather imaginative name image.ping, and we're going to put it into my tilde. And we're going to hope that was right. It was! Yay! And now we'll do image.ping. You can see I've done this a lot of times, and drum roll, we get a very grainy picture of the Cornell box. So the Cornell box is something that was made at Cornell University to, it as a physical object, right? Literally like colored card and cubes that were then photographed and used as a benchmark against which rendering technologies could be compared. This is a modified Cornell box because they did not have like an infinitely smooth circular sphere balanced somehow in the view, but I've added one just because I wanted to show off the sort of mirror ball that I had. So anyway, that is that's the kind of output of one of the scenes that I have. That's with 16 samples for every pixel. So I was kind of explaining how path tracing was working. The trick between path tracing and traditional ray tracing is usually with ray tracing, you fire the ray, you see where it lands, and unless that surface is specifically shiny or specifically mirrored, then that's where you stop. And at that point, then you go and look around and say, where could the light have come from? And you look at specific objects that are tagged as lights, and then you do some kind of simplified sampling of like, well, can I see that light? No. Can I see that light? Yes. So I'm shadowed from the light on the left, and I can receive light from the light on the right, and because of our angle between, this is how bright I'd be. And that's great, and it produces some lovely images. But it does not allow for secondary, tertiary, quaternary, whatever the fourth one is, bounces of light. What path tracing does is it says, fire the ray out, hit some point in the scene, and then randomly fire another ray from there. And keep going until you happen to either run out of time and patience, in which case, I don't know what happened there, or until you happen to hit something which has its own light. Like it has an intrinsic emission of light in it. So lights are not special in this world. And so there is one light in my view, my scene here, this is at the top here. Every single pixel down here has been lit because I fired a ray, that ray has bounced around millions of times until it eventually hit the light source. And then the whole path of light backwards from there is coloured by the interactions that it has with the scenes, with the surfaces that it reflected and refracted off of. Okay, so that sounds really complicated, and maybe it is, but the cool thing is, if I now zoom into this, and I don't know how well this comes out in the video, because we've obviously got a very grainy picture here, but you can see there's a white light at the top, and then this box has a red hint on the left-hand side. The box itself is perfectly white, and it is not reflective or refractive in any way, but the light that's arriving on the left-hand side of that box can only have come through bouncing off of this red wall. So it's as if the red wall to the left is in fact a light source of itself. And it's cool because we get this colour bleeding happening up here. There's a sort of greenish tint up here, there's a pinkish tint up here, green down here. It's just really nice, and it just works for itself. And although I made it sound very, very complicated when I explained how the light bouncing works, it's actually really, really simple, which means it's a perfect thing for me to show that has a relatively small amount of code, and yet really interesting viewpoints or outputs. So that was only 16 samples. What I might do is, let's just go to all the samples, and again we're going to make that num CPUs not but 8. So this is how many? 250. I think 100 is ample actually, based on the experiences that I've had so far. So, and again, kick that off because excuse me, while we're talking, we might as well have something going. Oh, that's 1024 by 1024. That's quite a large image. We don't need that big. Obviously, the number of pixels rather changes the amount of time it takes to render. And of course, this is not an efficient rendering technique. There are ways of making it more efficient. There are definitely really simplifying approximations that one can use that start getting very, very clever. But the cool thing about path tracing is that if you just leave it going long enough and with a decent enough random number generator, it will do pretty much a perfect render. There's no kind of aliasing or artifacts that come from anything that are from approximation. So like in a traditional game, I mean, forgetting all of the RTX stuff, you actually have hardware that can draw triangles, and then as you're drawing the triangles, for each pixel of the triangle, you're determining whether or not what lighting it has based on a set of heuristics mainly. And air does scatter light as well. Yeah, you can definitely do that. So one of the things I would love to do is, volumetric fog is relatively straightforward to do. You can work out how long a light trace went through open air, and then you can attenuate it and give it a reflection, refraction. You can give it a chance even in open air of being kinked off of some like particulate matter that was in that air, and so that can kind of gives you like hazy fog, where things that are in the fog will actually like light the fog up around them, which is pretty cool. And you can also do subsurface scattering, which is something I really want to put in. Subsurface scattering is the thing. How bright am I? Not very bright, but if you hold up your hand and put it in front of a very bright light, then you actually can see inside of your skin almost, and you see like the reddish tint of the blood that's inside your hand, which is kind of eerie, but cool. And a lot of surfaces have this. This is where the light has gone into the surface, bounced around a bit, and then come out from some other part of the surface. So there's a lot of really cool interactions you can do, and they just naturally fall out of the code. They not as it's written right now, because I'm very much a collide with surfaces. Not within those surfaces, but it's relatively straightforward to add, and it's definitely on my list of things I would love to do. It just makes things look really cool, and I have another model that maybe I'll render up in a minute that is it's just crying out to have some subsurface scattering to make it look like a sort of jade thing. Anyway, we're not done much coding so far, although there is a very cool image coming our way, so you can see the difference between 116 samples shortly. So the way that the code is organized is I have a source and a test directory. The tests mainly test the math library, and I started out with the math library being itself extremely kind of object-oriented, and over time I've extracted more and more of some of the primitives out into individual OO or FP directories for object-oriented or functional programming, just so that I have the leeway of making changes to what are essentially the basic building blocks, so that they're more object-oriented friendly or more FP friendly. Now that doesn't make so much difference until we get to the data-oriented design stuff, but let me give you an example of that. So one thing that is definitely shared among all of the food groups, all of the different ways, is the vec3 that I've written. And I know that there are libraries that one can pull down, of course. That's not really what this is about. I want to show how the code all fits together, and that means that I need a bit of control over the specifics of things like how a vector. So a vec3 is not like a standard vector. This is a three-dimensional point, or a three-dimensional vector, or a three-dimensional normal. Now, all three of those things are effectively just a tuple of x, y, and z double precision numbers. And I have got some ideas about actually extracting some stronger types for like normalized vectors and things, and that's a whole other area of investigation. Now the problem with this is it's so fun and so interesting that one wants to extend it and do more work and add new things, and I have only got a limited amount of time, which is of course until next month sometime. I've actually got 2 talks to do, and this is only one of them, so I'm a bit fretting. And I have to finish this before I can start the slides, but it should be all right. It should be all right. All right, this is not panicky. So anyway, this vector 3 here it's the same on all 3 of them, because there's no way I'm writing a cross product more than twice, because I can never remember how these stupid things, which way around these things go. And once I got it working, it was great. And I have tests for that, and that's lovely. Ray also is another one of these things. Array is basically 2 vec3s bundled together. And an orthonormal basis, we don't need to go into what that is right now. Approx vec3, that is only used for tests. It allows me to write tests that say, hey, this thing should be approximately this other thing. So that's cool, but originally things like spheres and triangles were in the math library because they seem sort of platonically perfect to go into a math library. You could have, a triangle is like 3 points and some other information and material and whatever, and that starts to get a bit, actually that's not necessarily the best way to store it. It probably is for functional programming, it probably is for object-oriented, but when you start to go into the data-oriented design, then having all of the information about a single object collected into a single object, a single like a triangle being an object, an actual real thing that exists. The OO mindset obviously is that you pull all of that information, bundle it together, call it triangle, and give it behavior, and that's beautiful, and that works brilliantly, and that's definitely how I think. The FP world, it's a little bit less clear, especially C++ is FP. I mean, traditional, strictly pure FP may not even have types, and so it may just be a bundle of numbers that you pass around, Obviously, that I think that's a bit daft when someone does functional programming in C++. One still makes a structure that holds this stuff. So that's what I did. And so there's a structure that holds the triangle. In fact, why don't I show you these things while we're talking? Now, there's something that's nagging at the back of my mind as I'm saying these things, and that is, I don't know about you. Maybe it's a trick of the mind, but my progress bar here seems decidedly non-linear. Like, it seemed to go very quickly 5, 10, 15, 20, and now it's slowing down. And so I'm deeply worried that I have some like, not memory leak, because I've run those kinds of tricks, but some kind of like either problem in the measuring of my percentage bar, or some thing that means that each one takes a little bit longer than the previous. So that's a concern. Hold that at the back of your minds anyway. But anyway, coming back to this, we look at the 3 triangles that we have. So let's have a look at the OO triangle, and the OO triangle looks like this. It is an array of 3 vertices, an array of 3 normals, and that's basically, I actually haven't bundled in the material with this triangle, but I might do. That would be more OO, and then a triangle becomes like a reified actual triangle. I have got this primitive over here, and a primitive is like an abstract base class for intersection, and that each of the different types override. And then I think, is it inside scene that I define this? No, I can't remember. Gosh, it's been a while. Is it inside renderer then? Triangle primitive? Scene builder definitely needs to know how to do this. Scene. Oh, okay, they're actually inside the scene builder. That's a weird thing. So yeah, the triangle is like the basic object, and then they're sort of married with a material to make a primitive. And inside the scene builder, I have 2 instances of primitive. There's either a sphere primitive or a triangle primitive, and then the sort of driver code will call add triangle and add sphere, and that will make unique pointers to those things so that my scene can hold all of these different objects. And that's very OOE. It means that the renderer just says, hey, call intersect. It doesn't care what it's intersecting with. So there's a comment in the chat here. Isn't it kind of noisy and bureaucratic to write? No, it is absolutely noisy as heck. Yes, that's true. I'm not here to comment on C++ itself. If you've used C++ a lot, you know that backwards compatibility is the biggest issue. Now, to your point though about whether no discard should be everywhere, this is a new warning that has been put into one of the tools that I use, and so I've been accepting it as a default to say yes, add the no discard. I agree it's noisy. I don't like the no accept as well that you'll see in a bunch of places. There's the may discard would be just as noisy. There are just as many places where you are like, actually no, you could discard this, as there are places that are like, no, you should probably not discard this thing. So a lot of this is me trying out stuff. So an example where, let's go to a triangle where there is actually, no, a triangle. Vec3 had a whole bunch of these things. Where is it? Yeah, so some of these make sense. So for example, normalize. Normalize is a function which you call, which does an in-place normalization of the vector. And as a convenience, it returns a reference back to the object, so you can chain operations. In this instance, you know, I'd have to put may discard, as I would have to do here and here and here and here. So there's about 50-50 between may discards and may not discards. Of course, you could use the same heuristic that the IDE, or sorry, the tool is using, which is that if you are a const method, then perhaps you should not have your output discarded. I'm not really going to get into that right now. It's an interesting point, and it's very, very noisy. I do agree. I tend to sort of blank them out, but like, yeah, this is daft here. Like, of traditional C, it would be double dot and then const, but here we've got it to be const expr, and it's no accept and it's no discard as well, and that just seems wordy. But yeah, all right, we're 75% done here while I'm talking. Let's kill the vector. Oh, I don't know why that happened. Let's go back to, we're talking about primitives, we're talking about, that's right, we're talking about the triangle. So the triangle in the OO case looks like this, again, noisy case of all the things that it can do. And if we then look at what the FP version of that looks like, it is essentially the same. I'll be honest with you, it's essentially the same, except with one key difference. You see, this is one of those examples of where I kind of had to go backwards and remove some things that I was doing naturally. And that is when I was sort of polling friends and colleagues about what they thought was functional programming in C++, they said things like use of variant, use of standard optional, and then I sort of like added in things like no mutable state as much as I can, using all the STL algorithms to do the work instead of writing raw loops. I mean, it's not strictly speaking purely functional, but if I'm going to come up with caricatures, that sort of fits into the bucket of more functional. So one of the things I did do in the OO version of the triangle was that the intersection method returned an optional, because it's very, very convenient for it to say, hey, if you hit something, here's what I hit, and if I didn't hit anything. That's just a nice thing to be able to say in a single thing, and optional is perfect for that. But when I went through my list of things, optional is very much an FP type thing. And someone's going to say monad, or I'm going to say monad. I've already said monad. It's not really monadic in the STL's implementations, as I understand. But so what I had to do is retrofit a NAF old school way of passing out in the OO version a bool that says whether or not you're returning something, and then an output parameter of the hit. And that actually changed the code quite a lot and made it a lot worse, in my opinion. But it means that the main difference between the triangle in the functional programming land and the triangle in the OO land is this optional hit inside the intersection, and it just makes the code look nice. So that's the two differences there. I've only just started on the data-oriented design version, and it's over here, and so it's called Spike at the moment, and it's a massive commented out code. It's definitely taking longer. And in the data-oriented design, my entire scene, and again, this is all sketch work, I haven't really thought about this, it's not even checked in, is that I would have the vertices of the triangles, the normals, and the materials of the triangles in 3 separate arrays. That means that while I'm looking for intersections with those triangles, the normals are not interesting, neither are the materials, actually. And the sort of data-oriented design is mantra is to like look at what calculations you're doing and design your data around those. So when, for example, the rendering code is saying, hey, I have a whole bunch of objects, what's the nearest one in this direction from a point, which is what you're doing when you're casting array in a particular direction. In both the OO and FP versions, we are throwing the ray into a bag of heterogeneous components. There could be spheres, there could be triangles, we don't know, and we're just hitting them in order, and each time they return, hey, oh, okay, I hit here, and we look and we say, is that nearer than the current hit? No, okay, that was actually a hit that was the other side of a wall, for example. And so we keep running through everything until we find the nearest possible hit, and then that's the thing we did hit. That's great, but when you have a data-oriented design, you're like, well, actually, most of the work that I'm doing to calculate those hits is wasted. I'm only interested in the nearest triangle or the nearest sphere, or in fact the nearest object. So why don't I treat those things separately and say, okay, first of all, find the nearest intersection point, and then and only then do the extra calculations to work out things like what normal it had and what material it had. And that means that while I'm racing through the giant array of triangles, I only need the information about their points, not their normals. So that's why we separated their vertices into one array, and then the normals and materials are in 2 other arrays. And then I've actually written the loop out longhand here. And this is again me sketching, and by this point I'm allowing myself to use FP techniques, even though it's data-oriented design. So the whole loop of which is the nearest triangle ends up looking like this, and I can actually discard things based on their distance without even having their normals or materials in my L1 cache, which should make it super fast, and it should also give the compiler a really decent optimizable block of similar-ish operations, which it does a good job with anyway, just to be clear. So that would find like the nearest point of intersection, and it has to remember a few pieces of information that are sort of like dynamic state of that particular operation, that particular intersection. And then only then, if there wasn't any of those things, then all right, that we didn't hit anything, Otherwise, now I can look up that information and do this work here. So this work here in the other two implementations is done for every found intersection, whether it's the nearest one or not. And I'm hoping that this is going to make it run super quick. Right, 1 second, coffee. And someone's just made a comment about Compiler Explorer. If you've got some Compiler Explorer ideas or issues, then please raise an issue in GitHub. This is not the place to be talking about that, I'm afraid, because this is very different. So anyway, that's what the data-oriented design version is looking like. And you can see I've sketched out the spheres version of the same. And what I really need to do now is work out how I'm going to break this into different pieces. I'm really worried about the speed that that's taking down there. It's also worth noting that the number of CPUs thing here is sort of conditional on the code supporting threading. At the moment, the only thing that supports threading is the original 00 version. What I'm actually probably going to do is extract that threading and make it single threaded again, and then have at least one layer of the talk where I show how easy or otherwise it is to multi-thread the various approaches. Obviously, FP is the most trivial to multi-thread, but saying that, there isn't much mutable state anyway. So even in a sort of very naive way of multi-threading, it kind of just works. So that's not such a big deal. All right, well, let's go and look at our image anyway. We've waited for it while I've been chatting, so I'm just going to copy this over the other one. And so if you remember how grainy that previous one was, we now have something which looks a lot nicer. And just to sort of bring it into zoom. Yeah, you can see there's a lot of nice things going on here. You've got this lovely sort of like light bleed around the light. There's a sort of a step down here. That's because the light itself is a rectangle that pokes through. The reflections happen. It's still quite grainy. That's an artifact of the sampling, but this is only 100 samples per pixel. You can imagine if you did 1,000, then there'd be no graininess left or something like that. And then you can always apply a slight smoothing filter. There are definitely improvements one can make in terms of doing dynamic sampling and interpolation, and I've been looking at some other path tracers that do that. It's a relatively straightforward change to do. There is the reflections are working. The shadows, obviously, I didn't even point these out before with the colors. So the shadows are naturally very soft because of the size of the light. I didn't have to write special case code, which I used to do when I was doing ray tracing. So anyway, there's a lot of cool things going on in there, and I'm quite pleased with it. That scene is tiny and simple and should render as fast in any method, no matter how clever you are. I have another scene which has many more triangles in it, and those that scene I'm assuming will be faster in the DoD version because actually we will blow through like the L1 and L2 cache. And then I'd like to come in at the end and say, well, actually, what we would do here is divide the world up and use some kind of tree to reduce the amount of triangles one has to intersect with, and then compare and contrast how much difference that makes. But that's another one. Yes, this is Sea Lion. Thank you everybody for saying that. This is Sea Lion with the darkular theme, which might make it look a little different to other people's, but it works pretty well. And again, this is me actually doing remote development. These things are rendering on a remote machine, which is nice. How are we doing for time? Oh gosh, the time goes so quickly on these things. So yes, my plan is to work out how I'm going to break this world up. Now, I haven't got a material yet. Why have I not got the material? Oh, because no, that's interesting. I wonder if I need to add something into this intersect triangles because it's not carrying currently the material. I think it will actually have to have something. Now I have something called an intersection record in some of the other places. So intersection record. Yeah, I've got one in FP, which is those type things, and that makes sense to have something in the DoD as well, which is not the Department of Defense. So I'm going to make one of those, and it is basically a hit and a material. So this thing should return one of those, and it should be pretty straightforward to make that intersection record of the hit of that of the materials I, wherever material is. Triangle. This is where it's going to get less interesting for those. So, but triangle materials, and it's going to be nearest indexed. Okay, I'll do that, and then I press the auto format button because I'm too lazy. Yay, everything just goes in the right spot. So now I have a function which intersects all the triangles. I should probably do the same thing with the spheres. And the trick also, incidentally, the trick where I only do the hard calculation work, excuse me, let me get my brain straight here. The work where I only return the information, including like the normal information and the back facingness and the material, I can do that in the OO version, and I can do that in the FP version. Of course, it's a relatively straightforward thing to do and a sensible thing to do. I'm deliberately not going to do it because I want to show that this comes naturally with the DoD and is somewhat unnatural on the OO and FP. Now, that said, if you look at Michael Fogelman's excellent Go-based path tracer, which has been a continual source of inspiration for this project, he has a really clever way of coming up with a sort of OOE method for this multi-pass thing where, you know, you fire your rays around, and then only once you've found the nearest spot do you do the extra work of sampling and all the other bits and pieces that will happen at that point. But I've chosen not to go that route just to sort of show this up. Okay, so let's try writing the sphere intersection version of this. So I'm going to just paste all the things that we have in front of there. And again, this is going to be array and that, and this is going to be intersect spheres. And I don't like these huge honking great big. Oh, DoD stands for data oriented design, which is a technique for essentially SIMD kind of stuff. SIMD, it's not necessarily SIMD, but you know, you're designing around the data access for the algorithm rather than the other way around. You're not designing your algorithm and then fitting your data around it. So let's intersect the spheres, and I mean, really I should write some tests for the first way, but let me make this slightly. Okay, we're going to have something which looks very similar to this. And we're going to say for size d I equals 0, I is less than, this will be sphere centers dot size plus I. See, I'd really love to use range for here, but I need the index, and it's not easy to use the range for and have an index. But I'm sort of toying with the idea of coming up with an iterator which looks like a virtual view over 3 arrays, something clever like that. Okay, but what I need to do now is steal, where is my sphere? Sphere.c, sphere.h. Okay, this is what the intersection code looks like. So I'm going to absolutely hideously thieve the whole thing. And this is a lot of code duplication, and that it's very, very hard to do this because I see code duplication everywhere, but it's actually useful because I'm trying to show how different one thing is 3 different ways rather than trying to extract some meaningful commonality between them all. So this will look like that, and anything that's returned that is like this did not hit, so this becomes a continue to say, hey, go check the next sphere. Yeah, data-oriented design, that's often what's happened. So Dimitri, if you look at, I mean, that's what, if you look at lines 52 through 58, that is essentially what I've done there. Is it what would have been an array of structures is now essentially a structure, the scene, of arrays of individual components. And although I've not broken them down into all the X's, all the Y's, all the Z's, it's like tuples of XYZ in one thing, different tuples of XYZ in another array. So it's a similar thing, but it doesn't have to be like that. It could just be moving around your members inside your structure so that they're more cache friendly. So for example, if you're a tree and you have the left pointer on in the first cache line and the right pointer like some other cache line, and you know that most of the time when you're traversing your tree you're going to go down both the left and the right pointer, then just move them so they're next to each other. And that is arguably, I believe, data-oriented design. So anyway, we've got that, and I need to say, right, so that's center there. So I'm going to do auto center, and I'm going to call it center underscore, which is usually my member variable name, but we're going to say auto const auto center equals sphere centers. Come on. Unfortunately, the IDE is apparently more sluggish than normal because of all the encoding that's going on in the background. Okay, so now, and then I'm going to, let's get, and so this is an interesting one, right? Because here the spheres and the radii are actually going to be used right next to each other. So I'm going to do this for now. I'm going to get it working, and I'm going to leave myself a note to do, should these be next to each other, question mark. And then I'm going to abuse the IDE to give these exactly, that should be called center, and this should definitely be, no, this one should be called, oh, radius. And then we could do all this stuff, and then radius squared is radius times radius. So an obvious trick here is to store the radius squared. And indeed, I might do that as well. There were points where I needed both the radius squared and the radius. But let's just have a look. Do we need that anywhere else? Where is radius used? Yeah, you can see it's used here. No, that's not what I meant at all. Sorry, I've pressed the wrong key. Oh, please go away. Yeah, I think that we're already, what we've determined is that in a data-oriented design, a sphere really is kept together. So let's go and have a look at our math sphere, no, there isn't one. Got it. All right. I am going to make a new class up here. I'm going to make it a struct for now. And again, this is all sketching, and hopefully in half an hour or so, when I've got something good enough to like think about and offline, I'll tidy this all up, add tests and things. But let's call this sphere. Each of these sub-projects is in its own namespace, so I can call things sphere without too much fear. Vec3 center double, and let's call this radius squared, because I deliberately didn't do this in the other cases, because if you make a sphere, you want to be able to have methods to retrieve its radius, right? That seems sensible if you're doing an OO type thing. And if you stored the radius squared, that means you have to do a square root. That felt unnecessarily wrong. But here I'm actually doing only one thing with this sphere. And so I will happily make that trade-off. So let's just call this spheres now. And so yeah, just to be clear in terms of the DoD, this Vec3 center is 3 lots of 8 bytes, so that's what, 8, 16, 24, and then its radius squared here is another 8 bytes, that's 32. So one of these spheres takes up half of a cache line. That means that every time I'm running through my array of spheres, I need to do a calculation with the center, and I need to do a calculation with the radius squared. Having them right next to each other means that I make one cache request, or the CPU makes one cache request, gets all of that in one go, and then I get on with my life. And in fact, I can fit 2 of these spheres in a single cache line. So if I have an array of them, even better, I only have to fetch from the cache every other sphere. That's brilliant. If I were to make this an object, obviously I'd write this the same way. It would be a center and a radius squared, but it's very tempting to start putting things like material in there, where I don't actually need the material unless there was an intersection, and it was the nearest one. So hopefully that gives some idea of my thought processes behind this. So now all this stuff gets changed. It's going to be spheres I dot center, and I'm not taking a const ref here. I'm already going to say this one. We're going to get rid of that. I'm going to say auto radius squared equals spheres I dot radius squared. Lovely. Yeah, that looks fabulous. I can probably inline that because I don't think that's useful to be named. Inline that. Oh, and it's just gone over the length. That's annoying. Okay. We'll come back to that in a second. All right, finally. Okay, so then this bit down the bottom here, these lines here, are the bits that are having found the nearest hit. What is the difference? So t is the distance. And so we will now say if, well, first of all, that return empty is not right. That's continue, because we're in a loop. And then if t is strictly less than the current nearest dist, then we can say, hooray, we have found the nearest thing thus far. It is absolutely a non-mechanical keyboard. It is a Logitech something horrible. This, the one that fits just about in my horrible keyboard tray, and I don't like, but is the least of all the worst keyboards I have so far. I'm surprised you can hear it. Yeah. It's the thing that fits in my tray that was left by the previous occupants of this house, so I'm sort of somewhat limited. So if it's less than the current nearest distance, then what do we need to do? I don't think we need to do anything, you know. I think the only thing I need to remember is we're going to have sort of slightly annoying t nearest index, and then we're just going to say nearest index equals I. Brilliant. Then all this stuff can come out of the loop. Okay, so that means this loop over here, why is it complaining? I need the index, you annoying IDE. Ah, you see, it's shut up now. So now I've been through my list of spheres, and I want to say if I don't have a nearest index, that means I didn't find a sphere at all. Then I didn't find an intersection, obviously. Otherwise, I can do all of these things here. Now this t becomes the current nearest dist. This center becomes the spheres of the nearest index, and because it's an optional, we need to go and do this. Nearest index. Now, dot center. And that becomes the back face thing, which is great. And then this is nearest, this is brilliant. Current nearest dist. And of course what we actually need to return is an intersection record of that hit and the sphere materials of star nearest index. Try and ignore my son choking to death in the background. And that's one of those closed. Alright, reformat everything and hopefully everything will make sense now. Okay, let's take stock. Alright, we are now complaining about different types of keyboard, which is perfectly reasonable for a Sunday morning. Okay, I think we have something which is going to work. We're going to go through each of the spheres that we have. I'm starting to try and teach myself not to call these things sphere index. I know it makes everything overspill, but it's much clearer than especially when you've got a ton of maths going on in there. Alright. And I've... Has that fixed up everything? Okay, yes, I think I've fixed it. It's a big file, this, which is obviously a sign of it needing to be broken up, and I'm not sure how I'm going to break it up yet. Okay, so now we can intersect all the spheres, we can intersect all the triangles, and that means I'm now just going to write intersect, which is going to intersect either of these things. And that should be relatively straightforward. So we're just going to call this one intersect. And this double nearer than goes away, which was nice. We can join those lines, we can add that there. Oh, we don't need to. Has that got everything working? Yeah. Is that the end of the namespace? Yes. Wunderbar. So the first thing we're going to do is we're going to say auto rec equals intersect. Let's do the spheres first. Ray, and in this case we're going to need stirred numeric limits. The nearest one so far of double colon infinity sphere rec. Let's call it that. Auto triangle. I'm sure there's a million ways to do this. Rec equals the same thing. Oh, except it's not the same thing actually, is it? No, the whole point. Well, let me write you what I was about to write. This is going to be intersect triangles. Now, of course, the point here is that if we've already found a nearby sphere, then we don't need to intersect the triangles. Yeah, sorry about my son in the background. You right, Isaac?
Yeah.
Yeah, he says, all right. All is well. He's been coughing like that for a few days. We've got sick animals. Somewhere there are 2 cats which have flu. And yeah, the cat flu, obviously. Thank you, yeah, for Captain Obvious.
One's right next to me.
Oh. Which one's next to you?
Sarah.
Oh, okay, the ill cat is next to him. So, right, the pair of them are just being ill over in the kitchen together. Okay, so this would find the nearest sphere and the nearest triangle, and obviously it would the nearest one, the point nearer than that, and I need to find the nearer of those 2, which is great. But here I don't need to. What I'm going to do is I'm going to say auto sphere rec equals that, and then this chap becomes, if I have a sphere rec, and this is where we really need that getor. There is a getor, isn't there? Which is very functional. I like that. Oh, hello. Come on. Value or, that's what it's called. Value or. See, the thing is, I actually want to do a transform on it. This is annoying. See, this is obviously not the functional programming thing, but here what I want to do is get a member out of that or return some default if it wasn't set at all. But here I need to actually spirit up an intersection record. So, all right, I'm going to write this the old school way, and then maybe I can think of a clever way. Sphere rec splat hit dot distance else infinity and beyond. All right, so in fact I think this is probably okay, I know I'm getting myself confused. Only one of these can possibly be oh no, it's we return if triangle rec is set, then we know that we intersected a triangle that was nearer than any sphere intersection if we had it. So if we have a triangle rec, then we're going to return triangle rec. Else we're going to return sphere rec. Splat. Oh, what do you call it? Minus arrow is too long to say. Okay. So I think that should intersect with the whole scene. Okay, so now we can start thinking about writing the radiance function down here. I still haven't written a test, so I feel slightly dirty. Yeah, there's a lot of code in that, but it's not actually that much. So I'm going to steal this particular thing, and then we're going to have to little think about how that works in a sort of data-oriented design kind of a way. There's a sort of more caricature stuff going on in there for the functional programming version. Okay, what are you going to look like? IDE is very angry. Wunderbar. So we were given a scene, which is this thing up here. We're going to say scene.intersect here. If I ever get control of my computer back again. It is essentially a coordinate system. So you get your fingers out and you point them like, you know, the old left hand rule, left hand rule, right hand rule kind of thing. And the thumb is in this case would be the Z direction, and then you've got like the X's and the Y's, or whichever way you like to think of it. In fact, normally my finger would be the Z direction. I don't know why I said that. So it'll be more like this. And we found a point that we've hit. I don't know where. Hang on a second. I can't even see myself. Where's the camera view? Yeah, okay, it's out of shot. So let me get a thing. Right. So our light ray has come in, it's hit the surface, and I've got the surface normal, and I want to generate a random ray in this hemisphere. That is the sort of the top half of an orange cut in half. I want to imagine there's an orange here, and I need to find a ray in a random. So there it is. We're then gonna do some number of sampling, and we've got a number of U samples, a number of V samples. This is like the very first hit as a sort of special case. I do a relatively even sampling of all the possible light directions, randomized still, but I do more than one, and then after that I just do one random one. So this sample range thing came from the FP world, and I probably don't want that because I haven't fully decided how that's going to go yet. So I'm going to go and steal the object-oriented renderer version. And you can see the to-dos everywhere. That's render pixel. Ugh, so much code everywhere. Okay, there we are. We'll do it this way. And actually we'll just do all of that. So it's essentially all inlined. This is me trying to be cute and use standard accumulate. Oh, is the stream? No, it could easily be that my internet connection. I've been having some problems recently. I'm sorry for the suffering it's causing. Let me just run my standard test here, because I was getting like at one point yesterday I was getting 60% packet loss pinging Google, which is seldom a good sign. But I unplugged the router and plugged it back in again, and things seem to be better. But all right, let's paste that in. And then delete all of that nonsense over here. So many different optimizations and so many different versions. This is so confusing. All right, so we've got a scene, we've got a random number generator, we've got U samples, we've got V samples, and I don't think we're using the sample scale in this particular one. We've got a basis. That's cool. I think we just need a vec3 result which starts off black, and we're going to sample around. And at the end of it all, I think we have to do some division. If I remember, there's some horrible. Yeah, this is not great. I don't like that. What am I missing here? How is this in the wrong? Whoops. Now you get to laugh at my programming. Have I balanced all the parentheses? I have. Excellent. We're still talking about keyboards over there. I'm hoping that the stream is better now. So we have samples, we've got new direction, we do some things, and we sample. That's pretty much it. I can't believe that. So that's this whole piece of code here, this radiance code here, is essentially the entire algorithm. It's just lovely that it is that small. And this is already more complicated than it needs to be, because it does reflections, which you don't need to do to get... it doesn't do specular, which I need to add in. Okay, well, we've got this radiance function. We should probably try calling it... totally infeasible this will work first time. But, oh yeah, I don't actually have a header for this, do I? All right, we're going to... I usually don't do this, but I'm going to actually make a header file so we can try calling this spike. New C++ header file. Add to targets, yes, actually. And we're going to call it .spike. And now, unfortunately, the IDE is going to do something daft, which I'm going to immediately delete. Thank you, Gareth. Pragma once, namespace, DOD, splat, pasty. Okay, in a second the IDE should catch up, and then I should be able to just Alt-enter my way through. Come on, slow computer. Okay, I think we're back. So I was just talking to myself rather crazily, and Xorg is taking so much. There's a lot of things going on my computer, as you can see. There's an awful lot. I'm not exactly excited by that. Oh, and finally, cannot create temporary file. Did I lose my internet connection? It's possible, you know. Oh no, I'm still on. Alright, well we're back now, and I'm in my DoD spike, and it does mean that I can basically Alt-enter my way into having everything just working. Ah, here's the interesting thing. Now I have to pull my my egregious hack. Oh, this is very unwell. The IDE is very unhappy. Let me try reloading. Actually, why don't I go for a local? I'm going to build locally for a second. So we're just going to go to local. Let it do its thing. It was clearly the synchronization to the remote host must have died, just like all of the just like all of the streaming thing did. Oh gosh, I'm losing my mind now, aren't I? Oh god, this has been going for longer than I thought it would. That's good news. Okay. So for purposes of getting this to just work, I am going to... What am I going to do? Because what I need to do is make this function so that we can actually call it. We're going to put this stuff in the header. And that means we're going to have to include all of this. No, you know where vector lives. Come on. Okay. Oh, that's right. All these classes need to be done. This is going to be pretty disgusting. I was going to try and get this working. I was going to try and actually render some stuff with it and see if it is actually any better. But that does mean I need to import all this nonsense into the header file, and this is going to get very ugly very quickly. So I'm actually going to stop that and come back to this. So for now, I will just say struct C. There exists something called C, and that shuts that up. Ray here. Come on. You're not going to find Ray? Okay. Fine, I know where it is. I don't like this. I wish the IDE would default to these quotes. This is like for project level things, I prefer to use that. There we go. And then this is from std_random. Okay, the autocomplete has gone on holiday. Yes. Hey, Luca. I was hoping you would be able to make it. I'm waning right now, I'm afraid, my friend. So you might have caught me just at the end. But the story so far is we're hacking on the DoD, the data-oriented design version of the Raycaster, and we've been struggling with a bunch of technical issues. Yeah, there's some Clang format. Clang format doesn't let you. Clang format in general does not change anything other than white space. So I've been unable to get it to do. So for example, you can't do east const, west const stuff with Clang format. So I've been very disappointed, unfortunately. But yeah, that would be ideal if I could say, hey, this is found in the project path, but I don't think that Clang format even knows where the files are, right? It doesn't parse and follow include dependencies. I had a script myself when I in my company 2 companies ago which would do it all for me, but that's a whole other story. So there is a number of horrible things in this DoD spike.cpp, and they probably even work. So I'm going to try now. Let's minimize that and actually do the right thing. So these triangle vertices here. Let's take this class and was it F6? I forget what move is. Aha! Try and use the IDE despite this. Okay, we want to move declarations. No, that's not right. Yeah, triangle vertices to existing on you. We're going to move them to, and this will be triangle vertices CPP in DoD namespace. And let's move it. What could go wrong? That's great. I want you to make it. That's fine. I don't care. Brilliant. Sort of slightly disturbed by the number of files that it seems to have edited there. Yeah, see, it's not exactly done a sterling job there. So triangle vertices is empty, and that's not helpful. That's not at all helpful. So you need to be in here, and this needs to be done the way I've asked you to, IDE, like that. No, not once mark. This needs to be in namespace DoD, and then we're going to go and basically steal all of those except for itself. We definitely don't need orthonormal basis. We definitely don't need ray. We don't need hit or optional or random or vector. So you did a terrible job, IDE. Unless I used it wrong, which is entirely possible. Okay, so triangle vertices.h has everything in the header, and then we just got an empty one of these things here. So let's just at least open up that. Okay, so now DoD spike.cpp, has this included triangle vertices.h? It has. Okay, well at least we've done that much. Let's go and fix those up. Was that something about Visual Studio? Yeah, Visual Studio is awesome. I haven't used it in about 15 years, but it was great then. Yay. Okay, that's not right. Okay, that is feeling better already. Okay, so we've got sphere is there. So let's extract this, and we're going to do this one manually because, frankly, I don't trust to IDE. So we're just going to make a header file. I'm going to call this sphere. Yes, dot spot. Why did he not? Pragma once namespace DoD splat paste include math vec3.h. That's all we're going to do with that. I can probably extract some actual thingamajigs in there at some point. Behavior, that's the one. Include sphere.h. Alright, slowly but surely things are starting to happen now. I'm going to go and fix the CMake list because annoyingly this hasn't put triangle vertices in there. Triangle vertices.h. Okay, splat, control F9. And I'm going to catch up with the chat. Mac users, they're okay. VS Code. Yep. C-Line had decent Yak Lex support. That's interesting. I'm surprised it hasn't. It's the kind of thing that I'd imagine there's a plugin for somewhere. Okay, I realised we hadn't built for a long time, which is sort of anathema to me. I usually build like literally all the time. And it is complaining because invalid initialization of type reference, blah de blah de blah. Because we need a scene. I think this radius function is going to eventually be a member function of scene, but for now, just to get this to shut up. Did that shut it up? Okay, scene, random number generator, ray, depth, UV, and preview. Ah, yes. Did I pass preview in as a parameter? It is there, so I just need to do comma preview. So preview is just like a special magic mode that makes it run really fast, so that when I'm fiddling around with the scenes, I can actually just get some kind of almost interactive view of it. So that's terrible for every kind of reason. Come on, preview and scene here, and then reformat all the world, and then control that, and then am I not even returning a result? Oh, I am. It's at the bottom there. It's just so bad. Oh, hello, cat. Are you going to come and say hello to everybody? Are you going to cough up her hairball? No. All right. She's the ill one. Okay. Apparently, still const dod scene from expression of type empty. No, I'm pretty sure that did that just not run. Okay, apparently we have 3 processes running. I bet you, again, yeah, okay, some kind of synchronization thing with that remote host is going wrong. And that's probably more a function of my NAF internet connection, which really shouldn't be. I've got a gigabit, for God's sake. All right, it's running now. Right, where were we? We've got this function here, which we can't call currently, because nobody else knows what the scene is to be able to make one. And we're slowly pulling the scene up into header files so that I can actually externally build this type of thing. And then we can actually do a render with it, and we can have a laugh at how badly wrong everything will be. Oh, hello, Greece! This is a wonderful European flavoured chat, even though I have a British accent. I'm actually living in Chicago, so it's nice to hear from the... So sad. I was going to say from the European Union that I'm still morally part of, even if my country has stupid ideas about that, or about 52% of it does. That's a whole other conversation. So anyway, what was I doing? I'm extracting this scene, and the scene we're going to have to define into section record. We might as well just pull that out into its own function as well, its own class while we're doing this. New C++ header file, intersection record. There's already a bunch of these. Yes. Pragma once, namespace DOD, paste. Wonderful. Hash include math hits.h hash include util. Ugh, you know a project's taken a wrong step when you have util all over the shop. Okay, so that's that extracted, even though the IDE is 100 years behind me. So this will be intersection record, and I think that means we have everything. I'm going to put that inside. Actually, I'm going to just call this triangle.h. Am I? No, I'm not. No. Ignore me. The funny thing is I'm not even using the normals. Yeah, that conversation's not worth it. Yeah, that's probably, you're right, probably, Gareth. It's probably the upload speed that's the killer here. I get, like, in fact, where's my Eero, which every morning does a measurement. Oh, my phone. God, everything's going wrong this morning. And apparently my network connection currently is 134 down, which is very, very, very slow. Oh, it took a nosedive on August the 8th from 500 to now it's been 100 for the last 3 days. That's no good. We'll have to fix that. Okay, so we've got it's probably a year since I got the new internet provider, and they've probably just gone. So you want to see a generated image? Yeah, we have one. All right, let me show you some. As I'm running out of steam here, and I can hear my wife is now waking up, which I don't want to subject her to listening to me. It's one thing with my son. But so far we have this image, which is very, very grainy and small. And this is the default scene. And if I go into my presentation, which actually no, it's in my root directory at the moment, I think. Yeah, hooray! So I was doing some rendering yesterday on a very expensive AWS instance, and there's some interesting things here. So I'm going to take a sidetrack here now. I'm going to obviously continue the DoD work and extract it, and hopefully find that it still works, and then write some tests and blah blah blah. And that'll be the rest of my day. How exciting for me! But just to sort of finish up the stream, as I'm going to finish up sort of now. The images that we have look like this. So I'm going to run EOG on that. So this is another image, and this is a much higher fidelity image. This is the one that has loads and loads of triangles, and therefore is a lot slower, and probably will work much better if I come up with some hierarchical acceleration stuff. So if this runs much faster in the DoD, which I'm expecting it to because the triangle intersection should be faster, then All right, no plan. So yes, I was going to say so this is me finishing up. If it's going, thank you, Gareth. Yes, the plan is DoD, make it go really fast, profile and discover that the time is all spent in this calculation here, and then sort of come up with some ideas of how could I make it go faster. But like many things, optimization, it's just better to be smarter than it is to be faster. And so there's a hierarchical thing I can layer on top of this that makes it go much faster. My suspicion is that will be easy to add to the OO version and easy to add to the functional programming version, but non-trivial to add to the DoD version, which will be an interesting kind of mix then. But we'll see. The whole point of this is that I have some ideas, I think, about where it's going, but until I actually do it, I can't stand up on stage and tell people, hey, this is a good way, this is a bad way, and whatever. So just to answer some of the questions that have coming up in the chat, I'm not following a particular tutorial here. Originally, like over a decade, about a decade ago, when I was at Google and I was experimenting with the then unreleased Go language, I found a path tracer written in C++ called smallpunt, which I have a version of inside the code base here, which is a reference. That's how I kind of learned about path tracing in the first place. Oh, it's my son kicking a ball against the window. And DoD is a data-oriented design. So I've done it there. I wrote one in Rust. When I was learning Rust, that was fun. I do have a book somewhere. Yeah, I've got this one over here, which is realistic ray tracing, which is not really about path tracing, but it's useful to have this kind of stuff. A lot of it, though, really does come from just a bit of leftover memories from the games industry as to how this kind of stuff works, and some just general interest I've had along the way. I haven't been following anything particularly. It's mostly my own jam. That said, most recently, Michael Fogelman's path tracer written in Go has been a source of inspiration. You should definitely check it out. It's brilliant, and he's excellent. So, yeah, that is it. So I'm going to leave this here for now, and I'm going to go off and have some breakfast. And I hope this is interesting. I hope this will be interesting. I hope I'll be able to stand up on stage and actually make a few interesting points that aren't just wild conjecture. The concerns are, as always, this is a toy project. This is a caricature of each design type, and so any conclusions I draw may not be really generally valid, and I think anyone who actually is either an FP expert or an OO expert or even or a DoD expert will take me to one side afterwards and say, well, that's not how you'd really do it. And that's my biggest concern, is essentially imposter syndrome. But hopefully it'll be entertaining. But I appreciate the comments that you've made in the chat. And I will maybe do some more of these in a morning session. I don't know. It's been fun. It's been useful to do this. But I'm going to go and spend some time looking at extracting the rest of this DoD. If you follow the path tracer project on GitHub, which I can't bring up now because my settings are all skewy, but if you search for PT-3, as in the number, as in the letters THREE dash ways, so PT3 ways on my GitHub, you'll find it. You can see where I am. You can even see my notes there. Some of those notes are actually the notes for the talk. The presentation is not yet shared and probably won't be. I'll keep that to myself. I want to keep some secrets. The questions on there. Stream down was a minute. Do I have DMs open on Twitter? Yes, I do. My email address as well is easy to find. It's my first name at my last name.org. Feel free to contact me if you've got some ideas or thoughts. And thank you for watching. I will catch you. Oh, thank you, Luca. I will catch you all another time, I hope. This has been it's been fun. Take care. Bye-bye. Enjoy your Sunday.